Right, we're going to start with some probability notation. First of all, P of A. Okay, P of A means the probability of event A occurring. And then P of not A means the probability of event A not occurring. An example of that would be if I tell you the probability of rain is equal to 3/7, then the probability of not rain is equal to 4/7. You should hopefully see from this that the probability of not rain is equal to 1 minus the probability that it does rain. Okay, and also hopefully you will then be able to see that the probability of rain plus the probability of not rain is equal to 1, so that the probability adds up to 1. Lastly, on this slide, I'd just like to point out that the probability of A must always be a number between 0 and 1. So we're now going to look at different types of events. We're going to look at independent events and mutually exclusive events. First of all, independent events. If two events have no effect on each other, they are independent. For example, rolling a dice and tossing a coin are independent events, as the number you get on the dice does not influence whether the coin shows heads or tails. And then that has implications for something called the multiplication rule. Okay, we say for two independent events, A and B, the probability of both events occurring is the probability of A and B equals probability of A times the probability of B. Okay, so if we focus on the example we used above about the dice, so if we say that event A is getting an odd number on the dice, well, that is a half, because half of the numbers on the dice are odd. If we say event B is getting a heads on the coin, well, that is also a half. Okay, because you can only get heads or tails. So the probability of getting an odd number on the dice and a head on the coin is equal to a half times a half, which is a quarter. You can see this a little bit more clearly maybe from a sample space diagram about why this rule works. So if we've got heads and tails on the coin, and we've got the numbers 1 to 6 on the dice, then you can see that there are 12 outcomes altogether, and these 3 outcomes have got a head and an odd number, and so that's 3 out of 12, which is equal to a quarter. The other type of event we will look at is a mutually exclusive event. So two events are said to be mutually exclusive if they cannot occur at the same time. Okay, so for example, when you roll a dice, you cannot get an odd number and an even number at the same time. So those events are said to be mutually exclusive. There's an addition rule for mutually exclusive events, and it says if we want to find out the probability of A or B occurring, then it's the probability of A plus the probability of B. And for the event of above, so the probability of getting an even number we'll call A, that's equal to a half. The probability of an odd number we'll call B, that's also equal to a half. So the probability of A or B is equal to a half plus a half, so is equal to 1. And hopefully that makes a little bit of sense to you, because all numbers on the dice are either odd or even, so the probability of getting an odd number or an even number when you roll a dice is certain, it's 1. So we're now going to apply our probability theory to a problem, and we're going to use a tree diagram to solve it. So if you can read the problem here, it says a litter of border collie puppies contain 4 females and 2 males. And the vet randomly removes one from its basket, it's not replaced, and then another is chosen. So what is the probability that the vet removes 2 males? So there's 2 situations. He could choose a male or a female on the first occasion. There's 6 puppies, so there's a 2/6 chance that he could choose a male and a 4/6 chance that he could choose a female. Now, he decides to choose a second puppy. So again, that puppy could be male or female. But now there are only 5 puppies in the basket. If the first one he chose was male, so along this branch, then there's only 1 male left. So there's only 1 out of 5 chance of male. There's still 4 females, so 4/5 chance of female. However, if he chose a female first of all, then there's only 3 females left. So there was a 3/5 chance of getting a female and a 2/5 chance of getting a male. So the question asks us the probability of getting 2 males, which means we want to follow the branch that's got male and then male, which is the top branch up here. And it's an AND probability, so it's a multiplication. So we're going to do the probability of male and male. And that will be equal to 2/6 times 1/5. Okay, which is equal to 1/15. Right, so we've added in a second part to the question. So it says, what's the probability that the vet removes 1 male and 1 female? So there's 2 situations in which that could happen. It could be male-female, or it could be female-male. So you need the probability of male-female plus the probability of female-male, which gives you 16/30. Okay, as in the case with all fraction questions, you can simplify your answer to give you 8/15. So if we just look at that situation, we've multiplied along the male-female branch to find male-female. So we'll give you male-female. We've multiplied along the female-male branch to give female-male. And then we've combined the probabilities. We've added the 2 answers together. So you multiply along the branches to find your solutions. But then if there's a combined event, you want to add those 2 solutions together. If we were just to complete this, this is the male-male that we found in the first part of the question. And down here we've got female-female. So now you should try and complete exercise 45, which is on page 142 of your textbook.